we, Japan, have long history to develop or deploy ITS. And maybe change colors. Red might be okay. So we started the first ITS. Okay, my definition, this is the first ITS in Japan. Okay, started 45 years before. Okay, in urban expressway network management. Okay, metropolitan expressway. And we first developed the traffic control center, like this. They are big, very big network board, and on the board there's a network, and maybe you can see the red part and orange part, and red part means heavily congested. Its speed might be less than 20 kilometers per hour. And orange shows a little bit congested. Its speed is more than 20, but less than 40 kilometers per hour. And so how do we identify those travel speeds? I already explained using the sensor. On the network. This network has so many sensors, and that's set every 300 meters, every 300 meters. Every 300 meters. And some person sit down before this board, and if they detect something happened like accident, they start to do some countermeasures to minimize the effect. They have several options. One strong option is to close the on lamps, which may affect, or which may add the more congestion at the point. And they always talk with the police staff in this building, and something happens, they talk deeply and decide the countermeasures, because only police has a right to decide. This company person cannot have a right to do anything. Just monitor and discussion, and operate under the guidance of the police person. But maybe this is the first ITS in Japan, very historic one, and we still use the same technologies. In this network, we have 3 control stations, control center like this. The network is separated into 3 parts, and each building have some responsibility for managing their networks, sub-networks. And using the data detected through the sensors in (1980s), so they started the travelers information services, to drivers. At that time, we don't have a mobile environment. only mobile environment or mobile devices can be the radio, okay, car radio. And a driver can get the latest traffic information, okay, travelers information through the radio. Okay. But not automatic. They should. Okay, they should adjust, okay, to set the channel of the traveler's information. Okay. And of course, on the network, there are a lot of variable message signs, okay, to inform where the heavy condition happened. Okay. Maybe during 1980s, we already had a lot of variable message signs, okay, on the network. And in 1996, okay, we finally have the first ITS devices on board, okay, on board. At that time, maybe around 10 or 20% of vehicles already equipped the car navigation system at that time, car navigation. And this VIX, I forgot the name. I mean information. Okay, a vehicle information and communication system, VICS, okay, VIX, was applied, okay, around 20 years before through the car navigation system, okay, like this. On the display, car navigation display, this kind of information automatically going down, okay, and displayed. In this case, occasionally no congestion happen. Okay, no congestion happen. If there is a congestion, some congested link might become red. Okay. Of course, this kind of diagrams, information provision, has been also provided through public network board on the link. Frankly speaking, there is no differences between this information and public information. Almost no incentive for them. Okay. Information quality is not big difference. There's not big differences of information quality between the onboard unit users and public information. Okay. Then, frankly speaking, this system has not been so much penetrated. Actually, I have this. But frankly speaking, Google Map might be more credible. Google Map. Okay. And the same year 1996, we already started the automated car control. Okay. Like this. Some platoon. And the following vehicle, basically, there was a drivers, but no operations. Okay? No operations. Then this is very, at the time, advanced. Maybe this was the first in the field experiment in the world. I believe. So this is on expressway link before the opening. Okay, before the opening. Okay. Maybe few days later, this expressway opened. Before that, we finally can do some experiment on the field. Okay. Automated. Autonomous vehicle experiment. Already done. Okay. More than 20 years before. Okay. After that, we had a lot of effort for driving assistance system, but almost failed. Okay. Almost failed. And our national government finally once gave up for researching the driving assistance system, maybe before year 2010, 9 and 8. At that time, I was involved in some project, but finally stopped. Finally stopped. Once gave up. Okay. And yes, as already explained in deep, we start the electronic toll collection system in year 2001. 2001. Okay. Like this. And this is renamed ETC 2.0. I already asked. Okay, this ETC system has been more and more had some functions, okay, due to the increase of the capacity of the communication. When we started the ETC system, the capacity on the communication between onboard unit and sensor are quite limited. Okay. Then we could only do is just for the toll collection. This was maximum at that time. But after that, due to technological innovation on the communication system, its capacity might be dramatically increased. Then we can add more function. Okay, more function. This is because we finally implement the advanced system of ETC version 2nd, okay, version 2. But I already told before, we decided the specification of this system maybe around 2007 or 8. Okay. Okay. Compared with 10 years before, currently the communication speed might be more advanced. And some device itself can stock more data. Okay. Due to the progress of media. Okay. Then this service is just started maybe year 2000. I forgot exactly, but maybe at that time, technological environment had been changed when we started to plan this. Okay. And as you know, recently, commercially we can use the location data through the mobile phone or cellular phone kind. Then now in the government, we are hardly discussing whether this kind of system can be more extended or not. maybe we already invested so much fun to develop and deploy this. But if its speed is very slow, and during such kind of slow deployment, if there is some big technological innovation, this kind of costly system might have some kind of risk. This is a very important lesson which the Japan can speak to all over the world. First, at maybe in the we have a big congress or conferences on ITS. Okay, annually we have it, and this year maybe in October, the Singapore host the ITS World Congress, and in maybe in early 2010, at that time, this kind of system might have attract great attention or interest from other countries, but currently almost no interest on this. So change of the technological environment so fast, okay, in this field. Recently, most of the interest by the attendance is Mars. Okay, I will mention in the afternoon. Okay, this is the first. Okay, again, that traffic management system based on the first ITS. Japan, of course, we need several processes, okay, to control the traffic flow. Okay, first, we should collect data. Okay? Data. Currently, we have around 6 information sources. Okay, but mostly this detector, okay, was still a very powerful tool for the data collection. Okay, so this company already invested this kind of system, and they of course well know the limitation of this kind of or cost of this kind of data collection system. Frankly speaking, they also want to change the data collection system based on some vehicle or mobile communication. But finally, they could not do. Because they had some kind of attachment to this system. Okay, and of course, surveillance camera might be another important tool to monitor the traffic flow. Okay, only the detector, it's very difficult to identify the traffic accident happened on the network. Okay, and we need this to identify the reason. Okay. Or sometimes these detectors work wrong to give a quite strange data. So we can check bilaterally using the camera. Okay. And after collecting the data, this data was transferred to the data center, okay, in the control center building, okay, central machines, and heavily calculate. Okay, heavily calculate. then providing the condition point and length, and those data can be transferred to the variable message sign or onboard unit. Okay. Okay. Then, sorry, mostly in Japanese. So we have a lot of measures of the information provision, okay, in this system. Okay. Like this is the most conventional, okay, variable message sign, okay, showing the condition point and its distance, and this is some kind of second generation using network figure, okay, on board. Okay. But those who don't know the network well, it's very difficult to utilize this. Okay. Then, okay, again, VIX, okay, and ETC 2.0, which are onboard unit style, and same kind of information can be provided on board in the vehicle. Okay? And some okay, this not only providing the congestion length, but for the travel time. For drivers, travel time might be preferable than congestion length. Okay. Travel time. And travel time can be estimated using both detector data and camera, AVI, automatic vehicle identification system. Okay. So there are detectors, and these can detect the speed, okay, travel speed, and we assume some link length, and using the network length data plus speed data, we can calculate travel time. But this is current speed-based estimation. After entering to this section, the situation changed. Travel time might be different. Okay. In this case, the precision of the estimation might be not credible. Okay. In the case, congestion length extended or minimized. Okay. But camera system, the same. They check the plate number and time difference. Okay. But and provide the real travel time. But this is also the kind of if something happens, this kind of information will not be credible, okay, reliable. So at this moment, we just only provide the current situation-based travel time estimation. Okay, So how do we provide more credible, reliable travel time might be our challenges. Okay. But frankly speaking, it's very difficult to forecast the traffic accident. Okay. And this in this network, congestion frequently happened. And a serious problem might be traffic accident caused by the traffic congestion. Okay. The end of the congestion, the drivers had some kind of delay to notice the end of congestion. Sometimes there is accident. Okay, gear to end collision accident happen. And but if we carefully observe daily, the congestion point might be almost same. Okay, almost same. In this case, we always inform the drivers in advance. Okay, if you drive more 600 meters, there is a traffic congestion, and please take care in this kind. So these kind of variety of information can be supported, okay, by the intensive data collection system and calculation system. But we already started this kind of effort 30 to 40 years before. Okay. System was so nice, so it's very difficult to change. If this is China, they can do quite different things from the beginning. Okay. Because 30 years before, they never have this kind of system. Okay. Okay. First session, 45 seconds. Okay. Oh, traffic safety, I dealt yesterday. Okay. That what kind of ITS concept, okay, or architecture can be applied, have been applied for the traffic safety issues is there are 4 dimensions. Okay, dimensions. Okay. Okay, easy to difficult. Okay, of course. How do I go back? Okay. Okay, easy to hard, difficult. Okay. First, we start from just providing a caution, okay, for some kind of risk. Okay, caution. So this kind of IT services, very easy. Just collect the data, analyze, and just provide the current situation. Okay, current situation. Okay. Second, we provide the kind of recommendation how the drivers should behave. This is more challenging for us because we recommend. Finally, the driver had accident. Who should be responsible? Okay, for that accident. So for road administrators, so this kind of recommendation system may have some kind of barrier. Then, still, the most of ITS services for traffic safety is just many of the services still this level. Okay. Technologically we can do, but socially this cannot be accepted well. Okay. So we always seek the balance between technological feasibility and social acceptance. Okay. And third one, some kind of function like driving operation assistance has been already installed in the market. Okay. As I mentioned, lane keeping technologies, or crash avoidance, or shock mitigation technologies, in the car, driving assistant. But still, assistant level might be one dimension. Okay. Stop or go. Okay. One dimension. It's very difficult to have a lane changing or merging, or turn at the intersection. Still have a big challenges. Finally, automation. This might be our ultimate target. But still, we need a lot of challenges to overcome the various problems for the automation. Maybe it may still need more 10 years or 20 years. Or finally impossible. I'm not sure. I'm not sure. Okay. But maybe still this or this might be already feasible. And this might be some social problem, and if we go to the 20 years later, what will happen? I'm so interested. Okay, and ITS is some kind of very should be attended by the various kind of technological field. Interdisciplinary approach we need. Interdisciplinary. Some of you are some mechanical, electronic, or civil, or urban planning, or others. So there are a lot of effort by those kinds of study field. And mostly, for example, your case, we have a central government. Central government. And your case, you have prime minister. Our case, same. We have prime minister. We have some kind of emperor, but he doesn't have any kind of right to have a policy, have some govern, make a governance. Just a kind of sign of the country. So our case, prime minister govern the cabinet office. Cabinet office. And in the cabinet office recently, IT, information technologies, ICT technology has very high interest by the Prime Minister or Cabinet Office. Okay. And the Cabinet Office also have Council for Science, Technology and Innovation. So this office take a lead the recent development of the autonomous vehicles development, deployment. And this is a current size, but around 5 years, until 5 years before, almost there's no link. No link. Because Japanese government or Japanese society finally realized the importance of autonomous vehicle development for the economic growth or to solve any kind of social problems. Then finally Cabinet Office has this strong interest and finally enter into this field and take a lead this. But before that, the governance of the ITS development and deployment was divided into several ministries. Several ministries. For example, this as an infrastructure transport, the kind of infrastructure development. They have responsible for the providing the infrastructure. Also, one of the main player in this ITS development. Because finally, any kind of devices can be applied on infrastructure. Still, only this ministry has ITS division in the Road Bureau. And communication, they control the communication system, or permission to use some kind of communication areas. Ban. So they control the ban of the communication. Then this ministry might be some very important players in ITS development. And Ministry of Industry, this ministry controls car manufacturers. Then, of course, this ministry has also important role on ITS. And police, as I already explained before, our case, police has a final responsibility for the traffic management. Then, at least we have 4 ministries, or agencies for the driving force of the ITS deployment and development. Of course, there are some kind of set up a liaison council, but in reality, they are always competing. So, no, there are some interaction, but maybe sometimes just fighting in many cases. But recently, the cabinet office became very strong. In these 10 years in Japan, some kind of change of the political structures. Then finally, cabinet office take a lead of the ITS development. This change happened within these 5 years. So we are not sure the ITS, how the Indian government think the ITS development and what kind of political structure they have, administrative structure they have. But maybe I believe many of the ministries may contribute to the ITS in India, and you need some kind of better governance. Okay. Who should have some very strong power to guide the better development. Otherwise, the situation will be same what happened in Japan. Okay. So we start very earlier, as I explained, but due to this kind of worse communication within the government, we finally have some kind of error over the deployment and development of ITS. Okay. Okay, I will change the time. So 1 hour and 45. Okay. First plan is 45 and 1 hour, but maybe 1 hour and 45. Okay, in this morning. Okay. So please allow me to speak more, less than 10 minutes. Okay. And okay, this is the time series information on our experience. Okay. Before this, of course, we have control center system. Okay, this is not included this ITS, but I want to include okay this. Okay. Okay, and maybe first car navigation system solved in the beginning of 1980s. Okay. In this chart, the car navigation might be the start, okay, of the ITS. Okay. And currently, 55 million unit car navigation. Okay. Okay, our population is 130 million. Compared with the population, this is so many car navigation unit already. Okay, equipped in the car. Okay. And in 1996, we first introduced the onboard information provision system named BIX. Okay, and 2001 ETC finally started its operations, and recently, maybe we have in Japan we have around 70 million cars, including trucks. Okay. Then, but this is, I think maybe around 50% of the car already equipped ETC. Okay, and currently, okay, sorry, and in okay, 2011. So we partially started the ETC 2.0 services. Okay, for information. Then currently the center of the ITS in Japan is, of course, this. Not only the toll collection, but for the information provision or data collection as a sensor. Okay. include everything. Finally merge into this. Then national government try to protect this. Okay, but the serious story I already mentioned, yes. From now, how do we think about this? Okay, because technological environment might be changed. Okay. Okay, and okay, basically there is an infrastructure, okay, and infrastructure cannot be changed radically, okay, or in short time. Once we set up the infrastructure, we should use this for at least 50 years or 100 years. Okay. Then, at first there's an infrastructure. Then, after that, we installed ITS services to minimize some bad impact caused by the infrastructure. Okay. This is a normal ideas. Okay. But I will explain in deep later. But some rare case, ITS service can change the concept of infrastructure. Okay. Sometimes. Our case, for example, this on the expressway we have rest area. Okay, rest area. Okay, and normally from rest area we cannot exit. Normally. Okay. Of course, we can set the on ramp and off ramp here, but without ETC, we should set a toll booth. Okay, and we should ask someone to collect the money, and it costs too much. Okay. Because recently they become privatized. Their motivation is to reduce the human resources in the company. Okay. Then, but if we have ETC, we can make the very cheap on and off ramps connected to the rest areas, and set ETC booth, and only ETC user can use this. Okay. And this, so normally we have so big interchanges like this, like this, okay, connecting the expressway to some national highways. So we need a very big on and off ramp structures here, and because if these toll booths are manually operated, we should consider some kind of queue. Okay, queue. Then, because it takes around maybe 10 seconds or more, okay, to collect the money. Okay, at this, but with ETC, this is almost 0 seconds. Okay, we can reduce the time. So finally, at this toll booth, we cannot expect the queue, okay, waiting for paying the money. Okay, then at this moment, we don't have to have a so big on-off ramp structures. Then we can use this. Construction cost might be dramatically reduced, as well as the land price. Okay, because we should acquire the land to develop this. In Japan, land price is so expensive. And the ETC system can reduce the infrastructure development cost. Okay, this is the story of this. Then we call this as, in Japan, smart interchange. What is smart but smart interchange? Okay. And originally, our expressway system in the law, interchange should be every 10 to 15 kilometers. Okay, we can set interchanges, but using this within maybe offer the people use more expressway. Okay, easy to expressway, having a more on and off ramps. Okay. Maybe we start this in. I forgot when we introduced this system, but this is a kind of one of the best policies in ITS. Okay. ETC 2.0 almost failed, but this had a big good result. Okay. Okay, ITS spot service already explained. Okay, already explained. So I will skip. Okay, so now that we have a break, okay, after coming back, so I will start the latest trials on the autonomous vehicle development. Okay, okay. Until now, this is a very conventional ITS information, but from now, the quite new one. Okay. Okay, so 10 minutes. Yes. Okay, so starting from 15. Okay. If you have a question, I can answer to the coffee break. Okay. 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 So thank you for again joining, and now still the part of ITS policy and measures in Japan and Tokyo, and I will use 10 or more 15 minutes on these topics, and I will move to the next one: issues and benefits of ITS. Okay. Okay, so the current movement, okay, in Japan for autonomous vehicle deployment, okay. Of course, this also the same as ITS, conventional ITS, cross-ministerial framework, okay, we need, okay, participated by a lot of ministries, okay. Okay. Ministries, and of course, the structure might be same. Okay, structure might be same. The players. Okay. Again, 3 measures. Okay. There's no communication, but of course some relation. Okay. Ministerial communication are not included in this framework, but again. 1 cabinet office plus 3 ministries, okay, structures, okay, and also cabinet office control, okay, in center, okay, collaborated with the other ministries, okay, because this autonomous vehicle deployment may have a very big changes, social changes, okay, providing force. Okay, everything might be changed, okay, including urban structure, okay, or social welfare, or basic living services, okay, sustainability, change everything, change everything. Then this kind of deployment can be or should be controlled in center, okay, to unify any kind of effort into one. Then this is because cabinet office may take a lead, okay, guided by prime minister. Okay. And under this cross-ministerial framework, the main discussion point, okay, might be not only the technological development, okay, but for institution, okay, what kind of governance we need, okay, and what kind of business model can be, okay, because mostly, okay, this kind of vehicle should be or may be treated commercially, okay, okay. Then we need a suitable, best business model for deployment of the autonomous vehicle, okay, in the market. Currently, still we need a huge cost, okay, huge cost. And if we finally have an autonomous vehicle, okay, it may be, it's very difficult to buy it, very expensive, right? Still, yes. So in this case, nobody buy it. Or for commercial use, okay, even though we are entering into sharing economy and nobody buy a car, but some company buy a car and operate. In this situation, if the vehicle is very expensive, no company buy it, okay, then considering the development cost, what kind of business model can be, might be the quite big issues, okay, to be discussed. Okay. And this is quite important, social acceptance. Okay. Social acceptance. Okay. I believe most of the Japanese or most of the people all over the world, autonomous vehicle provide, okay, the better, how to say, some living condition, okay. For example, for me, if I can use this kind of car, I can walk in the car, okay, during the commuting. The car might be the place of the work. And hopefully we can reduce the time for working. I cannot believe, but maybe inside the car might be another place of the working, okay, for working. Very convenient. And for leisure, currently, okay, I have wife and two sons. Going to the tourist destination, I always drive. Okay. They can talk, they can sleep, they can eat something, they can watch TV, but I cannot. I cannot. Okay. Then, if we can have this kind of vehicles, I can join. Okay. Talking, or sometimes playing card game. Okay. Okay, and sleeping. Okay. Sometimes I notice wife and two sons going to sleep. Get irritated. I cannot sleep. But if we have autonomous speaker, so we can avoid such kind of irritation. Okay, then there are a lot of benefit. But we are still wondering this system is safe or not. Okay. Sometimes, but this is the system and not perfect. Then we may have accident sometimes. Okay. In this situation, what we can do, or what society should do, and if the system still has some kind of risk, how the people can accept it. So this is quite a very difficult question. Difficult question. Okay. But for example, airplane. Okay. This weekend we have this sad accident. Okay. Happened in どうだっけ? Addis Ababa. Okay. Then, but death rate, okay, fatality rate of the airplane are quite small. Okay, quite small. Okay. If we take average, okay, take average, maybe almost same as a car accident and fatality rate. Okay. But even though we have sometimes very sad news of the accident, the airline system or airplane system has been already accepted almost for everybody. Okay. Then autonomous vehicle deployment might be or may have the same story. How do we accept this? Okay. Even though there still have a maybe potential risk of the very big accident caused by this system. So institution business model is not big matter compared with the social acceptance. So our challenge is how do we talk with the people, okay, as academician or technician. Okay. Of course, as an academician, technician, we should reduce the risk of the accident, but maybe not perfect. It's very difficult to achieve zero because this is technology and system. Okay. And now, when we start the car automation experience, I explained before in 1996. At that time, only this ministry did. Okay, did. Okay. But recently, if we have some field experiment of the autonomous vehicles, so we need a lot of effort. Then currently we have cross-ministerial and comprehensive and multidimensional research and development, okay, framework required. Okay. One of the examples is based on the very strong leadership of the national government or sponsorship. So one big project happened. Okay. SIP ADAS, okay, by cabinet office led by Prime Minister. This is so big research funded project, okay, and jointly by the car manufacturer, civil engineers, or transport planners, police. What else? communication, and others. Okay, and okay, there are a lot of field experiments we already have. Okay, for these 2 years or 3 years. Okay, I will explain the one example later. I was involved in it. Okay. Then some association of the motor companies, okay, or automobile companies or ICT companies, okay, like telecommunication. Okay. Some of the telecommunication companies had a very strong interest to enter into this market. Okay. And of course, university or government also have take a leadership in the field experiment. Okay. So any kind of sectors are now very curious about the field experiment of the autonomous vehicle deployment in Japan. Okay, so I said SIP, okay, SIP, ADAS, okay, have a so big research project, okay, happen. So maybe there are some English versions information in the site. So if you are interested, please visit to check. Okay. Okay, and this. So I have video image, but now today difficult. Okay, so 2 weeks before, I finally experienced to ride on the autonomous vehicle, okay, bus, okay, just 2 weeks before, 2 weeks before, okay, near my campus, okay, and okay, so currently we have various type of buses, autonomous buses, okay, now participating in the field experiment, and this is the biggest one, okay, like some community bus, a very small one, okay, just maybe less than 20% can ride on this. Okay, very small one. Okay, and this, okay, this company, okay, SoftBank Drive. SoftBank is telecommunication company. Okay, Japanese third largest. Biggest one is NTT Docomo. Okay. And third one is SoftBank. And the president of this company, Mr. Song, has a very strong interest to enter into this market. And he invests not only to many companies related to the autonomous vehicle development. Then they collaborate with one bus fleet company, the manufacturer company, and to develop these buses. Okay, and of course there are a lot of sensors like this, okay, to check the obstacles. Okay. Of course, it's very difficult, but some GPS receivers, okay, okay, and using the various kind of sensors, okay, to monitor the precise locations or to secure the safety conditions. Okay. And actually, these cars going. So this is the experience and route. A route was set in advance. Okay. Okay. And first trial. Okay. This bus can go only by the GPS. Okay. GPS. Recently, the precision of GPS become dramatically improved. Okay. Then maybe just a few centimeter or at most 10 centimeters has some precision. Okay. But this area in some new town areas, there are a lot of trees, street trees, and this due to some very dense vegetation of the trees, sometimes the precision of GPS become very reduced. Okay. Then this company checked in advance the feasibility of the driving using only GPS, but finally they gave up and to set this kind of marker, this every 10 meter, 20 meter, 10 meter or 20 meter. 10メーターかな。Finally, for secure the safety. Okay. Frankly speaking, in this condition, it costs too much. Okay. So we still need a kind of securing the precision of the GPS in any kind of environment. Sometimes there are some pedestrian bridge over the road. In this condition, GPS precision becomes reduced suddenly. Okay. Okay. And inside the car, okay, there's a kind of communication board with passengers. Passengers. Okay. For example, this avatar. The passenger can communicate. The person in the control center monitoring the in-vehicle condition. Okay. Now that in the experiment, the driver should ride on. Okay. But the driver doesn't touch the handle and press the pedal, brake pedals or axle pedals, but the driver should there, okay, in the experiment. Okay. Currently, our law never allowed the without drivers driving on the street. Okay. Now we are discussing how do we change this, okay, for facilitate more experiment, or to proceed to the next step of the experiment, more complicated one. Okay. Okay. And currently, so securing the safety, maximum speed might be just 20 or 25 kilometers per hour. Very slow. But at this moment, this might be the maximum effort. Okay. And of course, this is the bus services, and this should stop at bus stops. Okay, bus stops. Of course, if we well program, this can stop automatically. Okay, at the bus stop. Okay, and there is a pedestrian way, elevated, so bus should keep the minimum distance between the pedestrian way and bus free. So precision of the GPS might be the very important factors to realize this kind of approach to the bus stops closely. But I have that in this condition, it's still very difficult to keep the minimum distance between bus fleet and pedestrian way. Okay. But anyway, until maybe 1 year before or 2 years before, this kind of experiment always done in the private land. Okay, no field experiment happened. But recently there are a lot of field experiments in this kind, and now they collect any kind of data, information, and they stock the experience. Okay. So actually we start the autonomous vehicle experiment in the expressway. But frankly speaking, so expressway very easy compared with this. Okay, compared with this, and I expect the first car automation will happen for the freight transport, long distance, using expressway. Because now we are suffering from the depopulation, and it's very difficult to find the truck drivers, or bus drivers, for intercity. Then maybe freight transport and intercity bus services might be the first target of the automation, I believe, socially. Rather than this, those who formerly drive the intercity on truck or buses can be utilized for this kind of driving at first. Then finally we seek the automation in this field. But I'm wondering what kind of discussion happened in the national government regarding some order of the deployment, considering social needs. And for passenger cars, frankly speaking, that maybe never have a first priority for me. Even though I want to have a work in the car, or I want to talk with my family in the car, but this is not first priority, I believe. Firstly, we start from freight and public transport, then finally those kind of technology might be transferred to the passenger car in the last. Or if it allows, so after getting the cars, if car automatically going to the parking, it's okay. For me, this might be the very important function to buy the autonomous vehicle rather than driving on the expressway. So this is one idea. So I'm not sure this kind of idea can be shared by the other people, but this society of the autonomous vehicle deployment or development should talk carefully with the society. Yes, what is the most important function to do? Because at least in these 10 years or 20 years, we cannot expect a so perfect system on the automation. We should choose carefully the important functions. This is my view. My view. I'm not sure that other people think about this. Okay. Okay, so from now, I will proceed to the next issues, the final issues and benefit. Before that, do you have a question up to the our histories or future prospect of the ITS development in Japan? Okay, are you interested? Okay. Okay. So the rest of 15 minutes plus 1 hour, I will summarize my talk. Okay. What kind of issues, okay, and benefit in ITS? Okay. And this is my understanding, the important point. Okay. How do we make the ITS more having more benefit? Having more benefit. Okay. Okay. I like this word. Okay. Core technology first. Core technology first. Any kind of technology can be derived from only from the need. Even if we ask everybody what kind of technology you need, nobody cannot answer. Okay. So scientists or technicians think about what is important for society. Okay. And having some kind of passion to realize something, the technology might be developed, okay, and into market. For example, I always told some story of some music, okay, in the mobile environment, music. I believe recently you can enjoy listening music using mobile everywhere. But the one Japanese company, Sony, first developed the outside music, okay, listening system named Walkman. Okay, Walkman. Maybe beginning of 80s, 1980s, when I was a child. Okay. But at that time, nobody think who want to listen to music outside. Okay. But those who developed this Walkman strongly believe, had a strong belief that the people need this kind of technologies and will penetrate well. Well, finally, their willingness perfectly realized. Okay, realized. But at that time, they asked the people, do you think this kind of technology is important for you? Everybody said no. Okay. Then any kind of social system have some core technologies. Okay. Then, but this core technology might be never derived from the user need. Okay. Developers should consider, okay, carefully. ITS or autonomous vehicle, that may be almost same story. Okay. And once develop the core technologies, the next important task for us is to match this technology to the social needs, okay, and finally achieve the quality of life improvement. Okay. Otherwise, this kind of technology cannot be the social one, okay, and well penetrated. Okay. And in the ITS world, okay, I already explained in the first session today. So balance, okay, between infrastructure and ITS, ICT, or IT, IoT on the infrastructure. Okay. How much responsibility for the safety, or how much responsibility for congestion management should have, okay, both for infrastructure and ICT. Finally, there we need some kind of better balance between those. Okay. In the case Japan already have enough infrastructure. Okay. Then ITS or ICT, IoT might be might be the not so big load. Okay, just kind of adjustment. Okay. But developing countries, they are still lacking, suffering from the lack of infrastructure. In this case, ITS may have a great load. Okay, and in Japan, we start, okay, ITS. The first ITS was 1970s, but in reality, the name ITS started just beginning of 1990s. Okay, and after that, the government officials or academicians like me had some strong leadership to implement the ITS services into the region. Okay. I had a lot of tasks on this, but it was very difficult, and it's still difficult because the people in the road administration office are very weak for technology. So they cannot imagine what happened, even though we introduced some kind of system. So this has been a very quite tough challenges for us. Okay, I will explain later my experiences. Okay, in this viewpoint. Then process for implementing the ITS might be quite difficult and important. How do we talk with the administrators? How do we talk with the police? How do we talk with the people? Okay. How do we talk with the industry? Okay. And sometimes, okay, and to do this, okay, we need the good analytical system or ideas or data, okay, to make them rely on our proposal. Okay. Or sometimes there are a lot of barriers, but to overcome those barriers and to proceed to the field experiment, to show directly to the users of its impact. This is the most effective way, okay, to introduce the system in the regions. Okay. Okay. Okay, this is my viewpoint. Okay. This is my viewpoint. Okay. So the role of transport planning, okay, and management. Okay. If I'm allowed to speak in very short, very short, the role of transport planning and management. Okay. My answer is to provide the supply, matching to demand. Okay. Because we are responsible for supply, okay, providing the transport services to the users. Okay. Okay. And we should exactly know the demand to have a better planning and management. Okay. But frankly speaking, this has been very difficult. Okay. Recently, we have a various kind of data set, but still very difficult. Okay. So our task is to minimize the gap, okay, between supply and demand. I speak in the first day. Okay. And okay, so this conceptual diagram. So this vertical axis shows the flow or capacity. Flow or capacity. Okay. So to decide capacity, I believe mostly infrastructure decide. Okay. Maybe around 90 or 95% may be decided by the infrastructure specification, okay, capacity. Okay. Then, okay, rest of 10%, 5% or 10% might be covered by ITS. Maybe in Japan, frankly speaking, okay, we have well-developed infrastructure, and the contribution of the ITS in terms of the capacity might be not so big. Okay. But if this is okay, we apply this idea into India, I'm not sure. But this cannot be more than 10%, I think. But in your case, now compared with Japan, so ITS may have a big roles to decide capacity. And demand. Okay. Very, how to say, some difficult to deal with, because they have peak and off-peak. Okay. So maximum demand and minimum demand. Okay. But for considering the cost, it's very difficult to achieve or seek the maximum as the capacity, set the capacity considering the maximum demand. Economically, it's very difficult. Okay. Then we set some level. Okay. The basic Japanese standard. Okay, so if the hourly traffic volume, okay, so please, so hourly traffic volume. So in 1 year, we have around 90,000 hours in a year. Okay. Okay. Out of this, out of this hours, only 30 hours are allowed to be congested. Okay. Theoretically, okay. 30 hours. We give up 30 hours demand. Okay. This is a kind of concept of the how do we set the capacity. Okay. Capacity. Okay. And by ITS, we can control demand. Okay. Providing information or charging higher toll, this kind, to control the demand. Okay. Then, okay. So broadly speaking, in terms of the traffic efficiency, so role of ITS might be adjusting the capacity, increasing the capacity and adjusting the demand. And in terms of safety, traffic safety, okay, safety level. How do we secure the safety level? So there are 3 players. Okay. Again, infrastructure and car and ITS. Okay. Red. Okay. ITS. Okay. I'm not sure how many percentages of these. I think okay, compared with the efficiency issues, congestion issues, for ITS may have a big role in traffic safety. Okay. Okay. Japan, same, and India, same, I think. Okay. Then, if without ITS, so I think safety level cannot be achieved. Okay. This safety level is requirement by the users. So this should be explained first, but this is my understanding, the contribution of ITS. Okay. More noon time. Okay, so in afternoon session, okay, I will continue on this based on the based on the previous slide. Okay, and I will talk about some experience of the implementation of ITS into the region. Okay, and current movement, okay, and future perspective, including Mars deployment. Okay, then I will conclude my talk this time. Okay, so question might be acceptable in the last part. In the last part. Okay, thank you very much. So gather again in 2 p.m. Okay, take a rest.